Welcome to Maths with Jade. In this video tutorial, we'll be looking at compound interest and depreciation. In other words, repeated percentage change. To tackle this tutorial, you will need a basic understanding of percentages already, especially percentages using a multiplier. A link can be found in the description to a previous video I made on this. First, we're going to take a look at interest. Imagine I go to a bank and I deposit $1,000 at an interest rate of 5% per annual. This means per year. And that interest rate is either going to be simple or it's going to be compound. In reality, it's quite hard to find simple interest being used in the real world. However, occasionally it is used, so I will touch on it briefly. Simple interest is when the interest is based on the principal amount only. Principal amount means initial value. So in this case, P is equal to $1,000. So after 1 year, how much will I have? Well, I take my principal amount, 1,000, and I plus 5% of that principal amount. If you're not sure how to find 5% of my principal amount, then I don't think you took my advice and watched my previous video. Here's a little reminder. To find a percentage of something, we just divide the percentage by 100 and times it by the amount. In this case, 5 divided by 100 gives 0.05, times that by 1,000 and I get $50. So after 1 year, I have $1,050. So what about after 2 years? Well, I want to take my amount after 1 year and plus another 5% of my principal, which we already determined was 50. So after 2 years, I have 1,100. After year 3, I want to plus another 50, I get 1,150. After 4 years, I plus another 50, I get 1,200. And every single year, it just goes up by $50. I recommend solving simple interest problems using a bit of logic and common sense. However, I know some of you like a formula. So for those who want to memorize rather than think for themselves, the formula to find amount after T years for simple interest would be to take your principal amount and then plus your interest rate over 100 times by your principal amount times by time. If you were to plot simple interest over time, then it would go up in a very boring and steady manner like this. Compound interest is significantly more exciting and significantly more commonly used. Compound interest is when the interest is based on the current amount, which includes all interest previously earned. Which is great news if you're investing, but not so great news if you're borrowing. So starting with the same principal amount, after 1 year, I will have $1,000 increased by 5%. Now my multiplier to increase something by 5% would be 1.05. And this is because I can take 100% plus 5%, that gives me 105%, divide by 100, and I get my 1.05. If you are not comfortable with that yet, please go and watch my previous percentage video. That gives me the grand total of 1,050 after 1 year. The same as when I did simple interest. However, this is when it gets more exciting. Now, after 2 years, I'm going to take my new amount and times it by that multiplier 1.05. Essentially, compound interest means that you're getting interest on your interest. So if I carry out that calculation, I get $1,102.50. And then after 3 years, I take my new amount and I times by 1.05 and I get this. What happens if I want to quickly find how much I have after 8 years? Well, I don't want to work out every single year every time I do this, so let's look at what's really happening. To get from 1 year to the next, I'm just timesing the amount by 1.05. So if I want to quickly find out how much I have after 8 years, surely I can just take my principal amount and times it by 1.05 8 times. Which, if we want to do this very efficiently, we can just times by 1.05 to the power of 8. So after 8 years, I have $1,477.46. This leads me to a lovely looking formula to find an amount after T years. I just take the principal amount times by my multiplier to the power of time. And another quick reminder, to find the multiplier, I take 100 plus my interest rate and then divide by 100. If we were to plot compound interest, it would go up exponentially, which means as time goes on, the faster and faster it will grow. Let's see how this works in practice. Your neighbour comes up to you all excited one day and says he can finally refurbish his kitchen. And this is because he got off the phone with a loan company, and the loan company said he can borrow $5,000 at an interest rate of only 3% per month, and he has 2 years to pay it back. Is this really a good deal though? How much will he need to pay back after the 2 years? If the type of interest is not stated, we can presume that it is compound, which means the formula is P times m to the power of t. P is our principal amount, 5,000. M is 100 plus our interest rate, 3, divided by 100, which gives us 1.03. Do not be caught out here. Time is not 2 years, it is 24 months because our interest rate is per month. The total owed back after 2 years then would be 5,000 times 1.03 to the power of 24. And that gives us a whopping $10,163.97. I'll let your neighbour decide if he thinks that's a good deal or not. Here's a more common situation. I lock some money up in a bank. The initial amount I lock up is $13,000. And the bank are going to give me an interest rate of 1.5% per year. How much will I have after 10 years? Here's a reminder of the formula for compound interest. So I take my initial amount, P, 13,000, and I times it by my multiplier, which is 100 plus 1.5 over 100 to the power of 10. And this gives me $15,087.03. I might, however, want to know how much interest have I made? Well, to do that, I just take my final amount and minus my principal amount. And I have made $2,087.03 over the 10-year period. So that's compound interest out the way. What about depreciation? Well, it's very, very similar, but it's a compounded decrease in value over time. A car is a great example of this. Cars go down in value over time. So let's take a car with a principal value of $7,350. And the depreciation rate, D, let's call it, is 26% per year. How much will this car be worth in 5 years? We can use the same formula for this. However, there is a tiny difference. Because our value is going down, to work out the multiplier, we take 100 and minus our depreciation rate, and then divide by 100. So in this case, to find our multiplier, we take 100 minus 26, that gives us 74, and then we divide by 100. So we get 0.74. Now we just substitute our values into the formula, and we get the value of the car after 5 years. Here's some questions for you to do. They're all slightly different, so do read the question carefully. Pause the video now. Here are the solutions to those with how you should have got there. Please check your answers very carefully. Well done, you've made it to the end of compound interest and depreciation. This has been Maths with Jade. If you want to take this topic a little further, please look out for my problem solving with compound interest and depreciation tutorial. And if you like this content, please hit the like button. Subscribe to my channel for more content. Share this video and all comments are welcome. See you next time.